question talks about what's called a mid-segment, okay? So a mid-segment, I mean, it's kind of like exactly what it sounds like. It's a midpoint of a segment, but specifically, it's the midpoint of the segment of the side of a triangle, kind of, okay? So for example, if you look at this picture here, you have this side of this triangle AC. This point D right here is the midpoint. And then for this side CB, E is the midpoint. The segment created by these two midpoints, this is the mid-segment. Okay? So the segment created between those two midpoints, that's the mid-segment. Okay, that's what we're going to be talking about today. Now, this mid-segment turns out to be pretty cool. Okay, so this is what you wrote down in your theorem, your flip book. Okay, so the mid-segment, when you have a mid-segment, it does two things. So first of all, if you look at this picture here, D is going to be the midpoint between AC, and E is the midpoint between CB. So the mid-segment is DE. Okay, it does two things. DE, the mid-segment, is always going to be parallel to that opposite side. So it's the midpoint between these two sides. It's parallel to that other side. It'll happen every single time. It's pretty cool. Okay? Now the other thing, which is going to be really useful, so it just talks about parallel lines. Okay, those two lines, they're always going to be parallel. But what's also really interesting is the lengths of these two lines. Every single time this happens, you have a mid-segment. The length of the mid-segment is going to be half the length of that opposite parallel side. So if this mid-segment was 5, this longer side would be 10. Every single time. Okay, so those two relationships, pretty easy, pretty simple, but that's what we're going to be focusing on today. Okay, so let's jump down here. So the first thing we're going to talk about is using this idea of mid-segments to identify parallel lines. So remember, if you have a line that is a mid-segment, that mid-segment is going to be parallel to that opposite side. So the first thing you have to do is identify where your mid-segments are. So if I look at this picture here, remember a mid-segment, each endpoint, each end of it, is the midpoint of that side. So for example, R is the midpoint. How do I know R is the midpoint? These lines are talking about, right? This segment's congruent to this segment. Okay? So R is the midpoint. So R is the midpoint of DE. Okay. Now I know that T is the midpoint, right? Because these are both marked with 2. So I know T is the midpoint of DF. And what's my other midpoint? S. Yeah, right there. S is the midpoint of EF. Okay, so I have 3 midpoints. Now, you're not always going to have 3 mid-segments. In this case, we do. Sometimes you're just going to have 1 mid-segment. But in this case, I have 3 mid-segments. Okay? Now, the first one, you can pick any of them. If you connect any 2 of these 3 points, that creates a mid-segment. RS is a mid-segment. If RS is a mid-segment, it means it's parallel to that opposite side. This one right here. So RS is parallel to DF. There's one of your mid-segments. Then we pick another mid-segment. So maybe I pick RT. RT connects 2 of those midpoints. So if RT is a mid-segment, it is going to be parallel to the opposite side. Right? You see that? It's parallel to EF. F. And then finally, what's my last midsegment? ST, this one right here. And if ST is a midsegment, it is parallel to we'll use DR would work, it's the same line, but let's do DE just for consistency's sake. Okay, so that's pretty simple. So one idea is using the midsegments to identify parallel lines. Now, one thing I want to point out before we move on to the second point of midsegments, parallel lines have nothing to do with the length of the lines. Okay, I saw that on your guys' test whenever I was grading those. But a lot of people kind of getting parallel lines confused and saying, well, because they're parallel, they have to be congruent. That's not necessarily true. They can be congruent, and a lot of times they are, but just because lines are parallel doesn't mean they're congruent. Just because lines are parallel doesn't mean this one's half of that one. The fact that they're parallel has nothing to do, doesn't mean anything with the lengths, okay? The reason why we can find the lengths is because they are mid-segments. Okay, not that they're parallel, so we got to kind of separate those two things out. Parallel lines have nothing to do with the lengths of the lines. Okay, so try to keep those separate. Okay? Now, what we want to do next is use mid-segments to find the lengths. So not the parallel lines, but use the idea that, okay, they're mid-segments, so the mid-segment is always going to be half the length of that opposite parallel side. Okay? So if we look at this picture here, I have a bunch of mid-segments. I have point E here. I know that's the midpoint because those are congruent. D is a midpoint because those are congruent. F is a midpoint because those are congruent. So actually in this one they only drew 2 mid-segments, but I have 3 mid-segments here, right? So I have that one, and I have that one. And although they didn't draw it, you technically would have a mid-segment right there as well. So what happens here, each of these mid-segments, so for example, DF, if you were to measure that, DF is going to be half of whatever CB is. So once again, if this was 3, CB would be 6. Okay? So if we want to use this to find some lengths, it tells me right here, AD, so this little length here is 6. And then it says DE, so this length here is 7.5. Okay, now, they're asking me, I want to find the lengths of the line DC, line AC, line EF, and line AB. Now, before we actually get into this, I want to remind you guys about some notation that it seems like a tiny little thing, but it really is very important. When you see it written like this, and you see DC with a line over top of it, this is talking about the actual physical line DC. That's talking about this line right here. It's like if I were to talk about this as angles, this would be like if I was talking about angle A, that's talking about the actual physical angle. Now, a lot of times what we want to do with angles is we want to talk about, well, how big is it? What is the measure of angle A, right? So with angles, it's either angle A, which is talking about the actual angle, or if I want to talk about how big it is, I would say the measure of angle A. With segments, we don't say the measure of segment DC. To say how long the actual segment is, we just drop the line over top of it. So when I want to find the length of DC, what I can do is I can just say DC. When I see that, it's saying not the actual segment itself, but how big is it, okay? And then AC, EF, and AB. Okay, so let's see if we can find these 4. So the first one, I want to find DC. Well, I know AD is 6. How is that going to help me find DC? If AD is 6, how will that help me find DC? Okay? Because they're marked the same, right? They're both marked with 2 hash marks. So if AD is 6, DC is also 6. Okay, the next thing we want to do is we want to find AC. So that whole thing, right? How am I going to find AC? Okay. It'd be, right, it's two of them, right? 6 and 6. Yeah, it'd be 12. Very good. Okay. Next, we want to find EF. So far, I know AD, BC, AC. I also know EF. What's the relationship between FE, or EF, and AC? Yeah. They're parallel. That's important. But parallel lines have nothing to do with length. What's the relationship of their lengths? Great. Since it's a mid-segment, they are parallel, and this is half of whatever that is. So if AC is 12, half of that, it'd be 6. And in a similar way, if I want to find AB, this whole side, AB, what's half of AB? Which segment is going to be half of AB? What's the mid-segment that would be parallel to AB? DE. And I know, it's kind of hidden in there, but I did have DE, right? DE is 7.5. So, if DE is 7.5, what's AB? Twice that, yeah. Good. That's all we're doing today. It's pretty simple today. Okay, I don't think we've set up our table of contents. Maybe if we have, if we haven't, then let's do that now. So the next open page, if you haven't done it yet, should be page 63. So your table of contents is going to be on page 63. Your vocabulary should be on page 64, which means this should be on page 65. And this is section 5.1, and it is called Midsegments of Triangles. So first thing, using this idea that if I have a midsegment, it creates parallel lines. So the first thing we're going to do, we're going to look at a diagram, and we're going to identify 3 pairs of parallel segments. So we need a picture. All right, so let's do a big wide triangle here. Okay, and this triangle is going to be triangle A, B, C. Okay, then we're going to draw a triangle within the triangle, but the sides of the triangle inside are going to be the mid-segment, so it doesn't have to be perfect, but we should find maybe the midpoint of AB, draw it to the midpoint of BC, and then draw that midpoint down to the bottom. So, like I said, it doesn't have to be perfect. These are going to end up being mid-segments, so I might try to draw it that way as best you can. And then this triangle on the inside is going to be D, E, F. Now, although they kind of look like mid-segments, nothing they tell me says that they're mid-segments, and we can't assume that. We can't assume that it's a midpoint, but the other information they may give me may help me decide that it's a mid-segment. So let's say AD is 4, DB is 4, BE is 5, EC is 5, FC is 8, and AF is 8. So they still don't necessarily just straight out tell me that they're mid-segments, but I know they're mid-segments. How do I know that DE is a mid-segment? How do I know DE is a mid-segment? You?
It's made out of 2 midpoints.
Yeah, because D's a midpoint because that's 4 and that's 4. E's a midpoint because that's 5 and that's 5. So if DE is a mid-segment, it is going to be parallel to the opposite side. So DE is parallel to what? AC. Yeah, the opposite side there. Very good. Okay, what's another mid-segment? DF. Yeah, because we already said that D is a midpoint, and I know F is a midpoint because it cuts that in half. So if DF, side DF is a midsegment, it is parallel to AC. Excellent. And what's my last mid-segment here? EF. And if EF is a mid-segment, it is parallel to AB. Yeah, doesn't matter. It means the same thing. Okay, so that's one of the things you're going to be doing today. Easy enough? Okay. Now remember, mid-segments create parallel lines, which is really awesome because I know we have very fond memories of parallel lines back from chapter 3. Keep in mind though, parallel lines have nothing to do with the length. Because you could have parallel lines where one of them is this long and one of them is as long as the earth. Okay? Or you could have parallel lines that are the same length. Or you could have parallel lines that one is half the length of the other. The fact that they're parallel has nothing to do with their length. So keep that in mind. Okay? So the next thing we're going to do is talk about the length. Now, because they are mid-segments, the mid-segment is half the length of that opposite side. Nothing to do with the idea they're parallel. Okay? So, number 2. Let's draw some more pictures here. Okay, so it's going to be like a little sideways triangle here. Kind of. Going to do the same thing. So, draw some, the triangle within using the mid-segments. Like this. And that's to be perfect, but kind of get the idea. Now, once again, nothing they've told me so far, they kind of look like they're mid-segments, but you have to know for sure. So on this one, we're going to go ahead and mark those 2 sides, and then these 2 sides with 2. So I know for a fact I have at least 2 mid-segments, right? Because I know this is a midpoint. Actually, I only have 1 mid-segment, don't I? Right? That looks like a mid-segment, but I don't know that for sure. This is the only mid-segment I know for sure. Okay? So, keep that in mind. The other information we're going to be given is that this is going to be X, and this long side here is going to be 42. Now, what's the relationship between that side that's X and the side that's 42? They are parallel, but I'm looking for the length, right? I'm looking for the length. And remember, parallel lines have nothing to do with their length. So what else do I know? Yeah, this is half. X is half of 42, right? The mid-segment is half of that opposite side. So I know that mid-segment is 21. Now, if you want to work with the half idea, great, that's fine. I'm more of like an avoid fractions at all costs kind of person. So you can also think about it the opposite way. That 42 is twice whatever that is. So if instead you want to say, well, 2 x's, that's going to give you the 42. You get the same answer, you're still going to get 20. Doesn't matter which way. Okay, whatever makes more sense to you. Okay, questions on number 2? Okay, number 3. All right, so let's draw another little triangle here. So this is going to be a tall triangle like this. Going to have a line down this way. And we will have these 2 sides, those 2 segments are congruent. And then these 2 segments are congruent. And then this right here is 5x. And then that long side there is going to be 80. Okay, so what do I know here? What are some things we know? And it doesn't have to even lead to the right answer. What are some things I know? You're close and you have the right idea. What's the relationship between the side that's 5x and the side that's 80? It's half of it. Right? This, I know that this is a mid-segment because that's a midpoint and that's a midpoint. So remember, these aren't equal. They're not the same. this is half of that. So what does this equal? 40. Half of it. Not all of it. Half of it. Does that make sense? So x is actually going to be 8. Okay, not the whole thing. It has to equal half of it. Does that make sense? Okay. Let's do one more of these. So number 4. Let's draw a nice big triangle like this. A line across in the middle. And we'll do these two segments are congruent. And then these two segments are congruent. And then this middle one is going to be x plus 3. And the bottom is going to be 20. Okay, kind of similar to the last one. I know these two sides. What's the relationship between these two sides? Okay. X plus 3 is half of 20. So it's 10. So x would be 7. You're going to have a handful of problems that are just like that. Okay, questions on that? Okay, last one here. So some upfront information. Let's say x is the midpoint of UV. X is the midpoint of UV. And y is the midpoint of UW. X is the midpoint of UV, y is the midpoint of UW, and then of course we gotta have a nice little picture here. So my big triangle, the top is gonna be U, bottom left is V, bottom right is W, and then the line across is gonna be my X. Y. Okay, if I know x is the midpoint, what does that tell me? What do I know? Those two are congruent, and if y is the midpoint of UW, very good. So we also know this is the mid-segment of that. So let's say number 5, if xy equals 13, I want to find VW. If xy, so if this is 13, what would VW be? 26. Okay, now what about this one? What if the measure of angle UXY equals 80? The measure of angle UXY is 80. I want to find the measure of angle V. So they're telling me that this angle is 80. I want to find that angle. You are right. But I want you guys to think about it. You may already know why, but I want you guys to take a second to think about it. I want you to think about why. Maybe they can explain why. Well, I want you guys. Yeah. Okay. These are okay. Since this is a mid-segment, what do you know about these lines? They're parallel. And remember from chapter 3, all of those lovely parallel lines things. Have parallel lines cut by a transversal? What kind of angles are these? Corresponding angles, and corresponding angles are congruent. So it is also 80. Very good.